Okay guys, so as promised, it is 12:56. Those of you that asked me, Miss Mosley, when exactly will the video come out? So by the time you guys see this, you're probably in your beds or up doing something fun. Of course, you're not doing math, but it would have been nice if you were up studying, but of course it's Friday, or now Saturday. So I have given you a review of what will be on the test. What I'm going to do now, and this video will be kind of lengthy, but I will try to do it very quickly and make it as short as possible, is I'm going to go through a lot of different examples of what kind of things you can see. Keep in mind that this particular review is, again, I'm going to model certain problems, but then I'm also, again, wanting to still teach as I go as well. All right, so let's start with domain and range, which tends to give people a lot of problems, but then I think it's getting better for some of us, right? So keep in mind that there are worksheets that I have already posted that are in that Unit 2 folder, and just walking through this, I'm just do a couple of them. I know the lighting's kind of weird. Let's see. Okay, so for this one, hold on. Okay, I'm back. All right, so we're going to look at domain and range, and remember, there's a couple of straightforward ways that we're given to do this. So again, we can have it as a table, and again, this worksheet, it is in that Unit 2 folder that's under the general section for the class. So notice that you have your X values, you have your Y values. I'm trying to do something about the lighting. Let's see something for a second. Okay. Hold on one second, guys. Okay. I think I fixed the lighting, you guys. Give me a second. Yeah, I hope I fixed the lighting. There's not little blurriness. That's what I saw. Okay, so back to this. So they give you a table of X and Y values. We know how to do this. Basically, we list the X coordinates, and I like to do them from, again, least to greatest. So they're already in this form. You see how this -7 is smaller than -4, is less than -2. But keep in mind that when you do domain and range, use those curly brackets. So the answer to this one, of course, is we would put the we put the little curly bracket like that, some little squiggly thing, and then we just start listing with commas our domain. 8, 10, 19, and then close the curly bracket. However, just make a little squiggly line. Then if we want to do our range values, again, these are out of order, okay? So you can list them exactly like you see them. It won't hurt anything, but a lot of people tend to, again, you could just list them how you have them or put them from least to greatest. So we're doing this, okay? And so I'll just leave the numbers like they are. The issue is making sure that you have all the numbers. That's the biggest thing to show the range or Y values. Okay. The last thing I'm going to mention, again, it doesn't hurt that you just keep reiterating and showing, hey, they're talking about domain, that's the X. They're talking about range, this has to do with Y, just so that you're really clear and it keeps that vocabulary in your head. The other thing I would do is, even though this is saying find the domain and range of each relation, remember relations, there's another vocabulary word we've seen, those are ordered pairs. Ordered pairs. Another thing that I would do, this is just me, for just higher order thinking, is you could just say, hey, is that a function? Is this one a function? Right? So you can kind of go a little step further, even though the directions do not talk about saying if it's a function or not. And that's why I did it in the homework. So again, we listed the domain, which are X values. We've listed the range. This is super easy. Don't miss it. And then I'm going to go one step further, and I'm going to look at my domain and range values, and I'm going to tell you if it's a function or not. I'm going to do about 2 or 3 of these, and then I'm going to move on. So again, when I input in whatever this function is, they did not give it to us. They did not say, hey, f of x is equal to -2x plus 7, or f of x is equal to 5x squared plus 3x minus 2. I'm just making up some functions. But you are supposed to be able to, listen carefully, be given ordered pairs, given a table, given a graph of X and Y values, tell if it's a function or not. So when I look at this, I input -7 into some function, I get out 12. I input -4 in, I get out 9. I input -2, I get out -11. So one thing I'm noticing, 8, 17, 10, 6, 19, -5. All right? What I need you guys to hear, this is very important for some of you, and I could do some name calling. All right? Listen. It's not about, oh, look, Miss Felsley, all my X's are different and all my Y's are different. That's great that you find that relationship or that trend, but you need to show the relationship really between the X and the Y compared to this X and Y, compared to this X and Y, right? And so when we look at this collectively, I'm saying that there is one specific X with one specific Y. There are different X's with different Y values. So this is a function. So I would tell somebody, yes, this is a function. So I would put yes, okay, and then say something, it's a function. I'm just going to mark up these pages today. Okay, forgive me, it's late. So yes, this is a function. All my X's relating to the Y's, there was one specific X with one specific Y. Okay, let's go to another one. Let's jump to number 4. Okay, for number 4, they want the domain and range. So I put my little curly bracket, and I'm listing them from least to greatest, or what's here. So we got 3, 5, 7, 11, 13, and 15. Okay. All right, so I'm noticing they're all different. Now let's talk about the range values. That's the Y. So I have 14, 8, -2, 8 again, 0, and -18. Notice that as I go through this, what's really important, you guys, is that, I am comprehending what I'm writing down, and now I'm going to go back to the table, and I'm going to say, okay, I input 3, I get out 14. I input 5 into some function, I get 8. I plug in 7, I get -2. I plug in 11, I get 8. So everything is looking good right here. I have one X for one specific Y, and they're all different. And then I get 13, 0, and then look right here, guys. I input 15, I get out -18. So now I step back, and let me just say this. There's one error I've already made, and this is very important. Notice, okay, that when I was doing my range value, see there's an 8 here. There was an 8 again. You do not have to write it twice. So between you and me, I'm going to scratch this one out, because that's how I got you guys on the quizzes. Like I said it in class a lot of times, that you don't have to write duplicate numbers, okay? So again, but what I want to focus on now is this a function, yes or no? So I got all my X values, my domain. I have all my Y values, but right here, look. When I plugged in 5 to a function, I got out 8. But then I turned around and I plugged in 11, and I got out 8. And then remember, we go back to those questions at the top of the worksheet, and it says, ask yourself, is there one specific X for one specific Y? Ask yourself if there is one X with different Y's, or the last one is, can there be different X's, same Y? And that was a yes. So yes, it's a function. Okay? Yes, it's a function, because it's okay to have 2 different X's, same Y. All right, let's do one more. Let's look at this one. Pay attention to how I do this one too. So again, I'm going to write down my curly bracket for the domain. I have -18, -16, -10, -8, 3, and 7. But notice all of the range values are 11. So look, curly bracket, just put one 11 in there. Do not write 11, 11, 11. You don't have to do that. You see, it's redundant. So the question becomes, is this a function, yes or no? Well, I'm noticing that I have, again, different X's. All are different numbers. Pay very close attention. Same output. Yes, this is a function. Yes, it's a function. Okay, and again. So you can go through this worksheet if you would like. You could do number 2. You could do number 5 and number 3 and get a good understanding based off of what I just showed you here. Okay, so and one more time, what I will do is on the back of the sheet, let's just again talk about what is a yes and what is a no for a function. So yes, it's a function if we have one X for one specific Y It's a yes if we have different x's, same y. And it's a no. It's not a function. It's not a function when we have only this case, same x, different y's. Okay, and I went over that if you took notes on the review sheet too. I gave you examples. So make sure you understand this, pause the video, make sure you write this down, and again, make sure, even if you need to go to the recording from today, play it back, and I gave a couple of coordinate examples. All right, let's move on. So when we're back, time again for domain and range. So what if they give us ordered pairs? And what I want to stress to you guys is this worksheet right here, this worksheet, pieces of it, this was a homework assignment, and there were so many of you that did not do it at all. And so it's really important that y'all understand is you've already should have been doing the supplemental practice when I asked y'all to do it. Very important, because moving into the next unit, your homework is really going to hurt you if you don't do it. Okay, guys? No threatening, just telling you. Okay, so they give us relations or ordered pairs. Notice that at the top of here, again, I put domain, find the domain, those are my x values, and range, there's my y of each relation. X, y is the ordered pairs. Okay, now I did in this case, I circled in black all of the domains, in blue all of the ranges. So I'm just going to go to another one. Let's zoom in real quick, and I'm going to focus this. Yeah, let's see if that, there we go, nice and clear. All right, so let's go to number 4 very carefully. So I'm going to start listing my domain. You can skip through this if you get it, but I think make sure you pay attention to, is it a function, is it not? So I'm putting my 0, I'm just using my finger, -12, 9, -6, and 8. And between you and me, again, there is mathematically, they like least to greatest, but for this time, and just so y'all understand, just list them. You don't have to worry about, oh, Miss Mosey, what about order? Or do I need to put them from big to small? Just list it, you'll still get credit. All right, now we're going to get the y values. I'm using my finger, -4. And I'm saying it aloud, -9, +9, a 3, a 4, a -3, and a 2. So far I'm looking at it again very carefully. I don't see that I have, again, set a number more than once, okay? So again, 5 is input 5, I get out -4, input 7, I get -9, input 0, I get 9, input -12, I get 3, input 9, I get 4, input -6, I get -3, input 8, I get out 2. Okay, because, and I'm saying, remember, x is our input, y is the output. All right, there we go. Now, the other thing I'm going to say to you, very important, is I think what tripped a lot of people up is some people are like, oh, Miss Mosey, I see a +9 here, and I see a +9 here. Well, don't try to worry about the fact that, like, with these two different coordinate points, that there's a 9 here and a 9 there. Just focus on this relation, 0, 9, 9, 4. Okay, it's okay that this is an x of a 9 and that's a y of a 9. Doesn't matter. So the question is this a function? And I say, yes, it is, because I'm noticing for every x that's put in, and they're different, there is a different y that's coming out. So again, I don't see any overlap. I don't see another 5 in the x position. You know what I'm saying? Anywhere. I don't see another 9 in the x position. That's going to make me think about, oh, I have, same x, do I have different y's? So this is a yes. It's a function. Okay. So let me look for one at a glance super fast. Let's go to number 8. I'm not going to worry about the domain and range. I think y'all get the point of that. But let me just do this one super quick just because I see an overlap. So curly bracket 3, -3 for x, 1, -6, comma, -6. There's a 1 again. I'm not going to write it because, again, I have a 1 here. Just write it one time, and then -20, and that's it. So I wanted to show this one because don't write 1, comma, 1 again. All right? And then I'm not going to worry about the ranges. So here comes the question. Is this a function, yes or no? Well, when I look at these ordered pairs, one thing I'm noticing is I notice I said 1 like I said it 2 times in the x coordinate position. I said 1, 4, and 1, 3. So that's going to make me highlight it, both of those. And I'm going to ask myself, can I have the same x and different y's? And of course the answer to that is no, because we go back to the notes and it says if we have the same x, different y's, no, it's not a function. So again, that's not consistent, that if I plug in 1 minute, I get a different y answer. And I also tried to show this in class. I'm going to just show y'all something super quick. So if I have f of x is equal to like 2x plus 4. So if I plug in a 1 into that notation, I would get 2 times 1 plus 4. So f of 1, when x is 1, the output would be a 6, because 2 plus 4 is 6. So again, I can't turn around. This has nothing to do, guys, don't stress, nothing to do with this. I'm just giving an example. So I plug in 1, I get 6. Well, there's no way that given this function, somebody can turn around and say, hey, when x is 1 and you plug it in the function, you get out 10. That's not consistent, because if I plug in 1 into here every time, what am I going to get out? I'm going to always get out a 6, not a 10. So that's why you cannot have, again, same x, different y's. I hope you understand that now. So number 8 is no, not function. Okay, that's it. I think I've hammered on that. Okay, now let's talk about discrete. So one thing I will tell you is there is a discrete graph, 1 or 2, I think, on the test. You have to be comfortable with ordered pairs. So I'm going to go through 2 of these, and then I'm going to move on, because this is like from 6th grade. So listen carefully as I do this. So I'm going to do number 10, and I'm also going to tell you if it's a function or not. So here is 0, 0. Okay, there's the origin 0, 0. Remember that when we do x, comma, y, we move left or right when we do the x. For y, we move up and then down. So let's be clear. If I'm here at 0, 0, let me zoom in. I must love you guys. I am so up. Here we go. So now, if I want to go to this point here, notice I'm paying attention to a lot of things, analyzing. My scale is by 2s. You see that? 2, 4, 6, 8. There's no 1, 2, 3, 4. Everything doesn't have to be 1, 2, 3, 4, 5, 6. You can go by 2s, you can go by 5s. So I'm going 2, 4, 6. So every jump is a unit of 2. So I say I want to go over here. So I'm going to go x first. So what do? I'm going to go left or right first. Well, to get to this point, I'm going to go 2, 4, 6 jumps to -6. And then I'm going up 1 jump. And again, the scale is by 2. So the coordinate for this one is -6, comma, 2. All right. Now, if I want to go to this point here, and this is quadrant 1, I would go 2, 4 to the right, and then I want to go up 2, 4, 6. So this is 4, comma, 6. If I want to go to this point here, I go back. We always start here, guys. And I'm going 2, 4, 6, 8 to get on top of it, and then I'm jumping down -2, -4. So this one is 8, comma, -4. How easy is that? And then this one, you got to look very carefully. It's sitting right on the x-axis. So that means I'm going all these jumps to -12, but I don't go up and I don't go down. So it's a 0 for the y. So this is -12 because we went 12 units to the left and we went nowhere up and down. And for the last one, I went 2, 4, 6, 8, 10, and I came down -2, and I came down -4. Each jump was worth 2. So this is -10, comma, -4. All right, so now that we know how to do coordinate points, and again, you're going to be asked a question about coordinates and how to basically make coordinates. Okay, so the next thing we should do is let's do the domain and range. So I put the curly bracket, and I'm going to just move from left to right. So I'm going to say, oh, look, -12 is my furthest point to the left. And then as I'm walking, look, you see, there's a -10 here. Then I keep going. The next point is -6. I'm only looking at the x-coordinates. So now I've taken care of these 3 points. I keep going. The next point is this one. So I'm going to put a 4. And my last point, I'm going to put an 8. And then close it. All right, now notice, and please listen and watch this. Notice how you see how I went from left to right? See how I went, ooh, negative 12, only x coordinate. Then I went to negative 10, this x coordinate, negative 6. Notice everything I did was from left to right. Now watch how I do the range. I'm going to do bottom up. That's the same thing I was trying to tell y'all with continuous functions. So I'm going to go down to the bottom. The lowest y value is right here, guys. The lowest point on this given function or graph is at negative 4, and they're the same. So I'm going to put negative 4, comma, and then I'm moving up, and there is, look, a point sitting on the x-axis, so y is 0 right here. So there's also a 0 for y. Then I go to this point right here, and I'm at 2 for the y, comma, and then the next point is this guy. And he has a coordinate, look, y is at 6. Hope that makes sense. And I wrote the negative 4 one time. That's it. So now, if someone was to ask me, 2 questions they can ask me. They could say, hey, is this a function, yes or no? And I would tell them, well, I see that there's one specific x, it outputs this y, this negative 6 outputs a 2, negative 10, negative 4. So you're noticing, look, they're all different x's with different y's, right? There's no repeat of x's, no repeats of y. So I'm going to say, yes, it's a function. And one more time, the vertical line test. If I take a vertical line and I put it through these different points, does it go through those points one time? Sure it will. So if I do a vertical line test there, here, see, you don't have to do this many, just to be clear, but I could have literally just put them through the points that were given, and sure, these vertical lines pass through one time. So yes, this is a function. Okay, yes, it's a function. The other thing I want you to know is when you have a discrete function, and let me also write that above, remember when there's a bunch of points and they're not connected, it's discrete. Okay, so that's it. So you can't put inequality symbols. Hear me when I say that. You cannot say, hey, x is greater than or less than these numbers. You can't say that because, see, they're just point, 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 point. There's no connectivity. All right. So now this one is not a function because, again, look, if I put a vertical line through the points on the graph, I mean, it was, see, it happens actually twice. See, it went through 2 points at the same time, which means, again, listen carefully, that there's an x comma 3, okay, I'm sorry, I said that so wrong. There's a 3 comma 3, and then for this x of 3, I got out a 9. You see, you cannot have same x, different y's. Look at this one. X is 9, because the scale is by 3 in both directions. 3, okay? So x is 9, and then 0, and then this is 9, negative 12. Cannot have same x, different y's. So this is not a function. It failed the vertical line test, so not a function. Okay? And then, of course, you would get the different ordered pairs, and you can list the domain and range. So I hope that makes sense to you guys, all right? So that takes care of those two. And these worksheets are, again, in the folder. Let me zoom back out. Let me find my next plan of action. Okay, so domain and range, let's talk about, one more time, domain and range. But let's talk about it related to a continuous function, which that's the part that gives people a hard time. Give me a second to find my papers. Here we go, I found it. All right, so now look at these. Remember, we can have some that have arrows. We can have some that start and stop as pieces. So here we go. So this is, of course, you know, those are continuous. And what I want to stress to you guys is that, again, let's do this one. There are infinite, there's so many, now I don't want to say infinite, because infinite would definitely be the arrows, you see like this? But I'm just going to tell you there's so many little points on this solid line. That's what I want to stress to you. So when we put things with the y is greater than or equal to 0 and y is less than or equal to 5, it's because there's so many numbers that fall between 0 and 5, right? 0.1, 0.2, 1.6, 2.4. It's a lot of numbers. That's why you have to say, hey, y is basically between 0 and 5. There's a lot of numbers in between there. Okay, so let's look at this one. I think I have 2 highlighters. Yeah, I do. Okay, so if they asked you and they gave you the function and they said, hey, what's the domain for this function B, for graph B? So here's what you would do. So when I think about domain, it's my x values, right? Domain x. When I think about range, y. So that means that if I'm going to describe the domain, I'm going to look on the x-axis. If I'm going to describe what's happening for range, I'm looking on the y-axis. Please understand that. So what I'm going to do, and you guys didn't like this the first time I did it, but I'm going to do it again. I'm going to show this 3 different ways. Is I tell myself look left to right for x, because this is the x-axis, and basically like a number line, all the x numbers are on, this horizontal axis. So I told myself, hey, if I go furthest to the left, and then I come furthest to the right for the function, right? Then if I put the coordinate here, going back, this is 0, 0, and we're going to say this is by ones, okay? So we got -1, -2, -3, -4, -5, -6, -7, and then we're going to come down, -1, -2, -3. So this point right here is at -7, comma, -3. That's a 3. Okay. I come furthest over to the right because, again, my boundary, my function starts there and then it ends there. Right? So I'm just cutting this guy off related to, because remember how x goes here, 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 here? See? Okay, so now this point is 1, 2, 3, 4, 5, and then up 1. 5, comma, 1. So now when I look at this, just to make this clear, is I'm telling myself, hey, the lowest value on this function for x is at -7. Then there's all these other numbers for x. Boom, 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 boom. -2, -2.5, 1.5, 1.6, 2.4. See? But then right here, and then the x ends at 5. So basically, my domain, I'm going to put it down here at the bottom. I put the x in the middle, and I read from this perspective. I say, hey, my x's are greater than and equal to, because there's a solid dot, -7. So when I walk along that function, you see, all my x values are being bigger than -7, everybody, right? But my x values are are less than 5. Because I'm not a 6 over here. The function's not over here at 8, 10, 20, It stops right there. And it's an open circle, so I say x is not equal to 5. You know what I'm saying? So hopefully that makes sense. So, and the other way I showed it was with colors, is I said, okay, if I have this point, I'm going to pull it down onto the x-axis and put a solid -7 there. And then here, I'm going to pull this x's coordinate down to the x-axis number line, and I highlight from left to right, you see? So what could your x values be? Your x values can be any numbers from -7 to +5, but not equal to +5. So all of those numbers for x are going to be in the function. You see? Okay. So again, I know it's tricky. All right, now let's look at y. So now for y, I'm looking from bottom up, right? So I noticed that y values are read off the y-axis. So I'm going to go like this. I'm going to look at the lowest y point right here, and I'm reading off of the y-axis. So I want to look right here. That's why I'm putting a horizontal line through the y-axis and through that point. So -3 is the lowest point, and then the highest point for y, reading off the y-axis, is here. And I actually think, oh, right here. So if I put a line going horizontally this way to cut off my function from bottom upward, then I'm saying right here, y is not equal to 1 because it's an open circle. Okay? So for the range, the way I would describe it, I'm going to use a color, is I would pull the y coordinate number over to where I read it from. So you see, I would say, hey, -3, that's basically right there. And then again, the highest number for y, but it's not equal to it, is 1. And so my y's are everybody between -3 and to 1, but don't include 1. And I know that I put a solid circle, so I apologize. It's just it's thick, and it's a highlighter. But it's an open circle, just to clarify. That's an open circle at 1. So the way we do the range is we're talking about y values. So you put a y in the middle, and you say my y values are equal to -3, right? My y values are greater than, because I'm moving upward. Okay, sorry. My y values are greater than and equal to -3, because they're increasing as we move up, but they are less than, you see, you come down, they're less than 1 and not equal to 1. I hope that makes sense, and I know this is so messy. All right, so that's that. Let me do another one, and I'll just do it clearly. So I taught it here very carefully. I'm going to move faster. Okay, now let's go with this one, E. So for this one, I'm looking from left to right. So I say, hey, right here on this axis, I know x is 0. So the butt of this parabola, these sideways, is at 0, 0. Okay. Now I notice that because I have the arrows, I'm just going to extend them off of my page, and I'm saying, look, I have no limit. I have no limit. You see? So I can't say, hey, my x stops. The graph stops there because it just keeps going for x. You see? So I'm going to say that basically my x values are greater than 0. Greater than and equal to 0. That's it. Because there's no stopping this function or graph. So the domain is x greater than or equal to 0. All my x values are greater than 0. I mean, if I keep going, I can get to 100, 1,000,000, 1,000. This thing's going to keep growing and increasing in the x direction. Hope that makes sense. Okay, now, this one's a little trickier. When I think of the y values, so I look from the bottom upward. Well, here's the deal. This function, again, is going to go. It's going to just go and keep going. So look, see? Bunch of negative numbers. No stop to it. It's going to keep going this way. Bunch of positive numbers. So the range is all real numbers. My y can be anything. There's no start at -2, go up to 7 or something. It just keeps growing and increasing here and decreasing at the same time there. So we're going to say that for the range, all real numbers. All my y values have negative and positive values, and they keep going. Okay? If we go to this one, same thing again, left to right. If I go here, furthest to the left, this point right here is at -4, 0. See, I'm at here, -1, -2, -3, -4, -4, 0. This one over here is at 4, 0. So what can I say about my x values? Well, let me also do this too. I basically can say that my x is equal, furthest to the left at -4. The x values are also at +4. And here's the part that I need y'all to pay close attention to. When you read the x-axis, when it's making this circle, all the solid line right here, there's all these infinite points. That's what I need y'all to understand. Is that if I go to x being -3, the output is like, I don't know, you guys, like 2 point something, 2.8. If I say x is -1, look at the output. You know, it's basically like almost like 4, so 3.8. So I'm just saying there's all of these values for x between -4 and 4. So the domain for this one, we're going to say x is greater than and equal to -4. All my x values are bigger and then equal to -4, but they are also less than and equal to +4. There is no anything outside of -4 and +4 for x. All right, so now when I look at the range, I'm going to look from the bottom upward. So I get my lowest y value, which would be here. My lowest point, on the function would be here. And this point is at 0 for x because I went nowhere right or left. So 0, but I came down -1, -2, -3, -4. So this one is at 0, -4. And then the highest point on my function is here, which would be at 0, 4. and I'm going to get another color, and I say to you, okay, lowest y value at that point is -4. Highest y value is at 4. So my range, because when you read the y values, where do you read them? You see, you read them this way, horizontally. Okay, so all the y values can be equal to -4 and +4 and everybody in between, because I get, look, this circle with all those y possibilities. I hope that makes sense. So the range is, again, y, the values for y can be greater than or equal to -4, less than or equal to 4. Oh, it's so messy. Now, again, please understand that and take your time. I think that's like the toughest thing for people. I hope y'all can read that. It's the same as this one. I'll just write it over here. Y, that's the range. Okay, and we can do this all day. Just so you know, we can do this all day. This one right here. Excuse me. Notice how I extended this line off the page. And again, it was all real numbers for both of them, because my x values, because this keeps increasing, or I'm sorry, decreasing this way, so x can be anything negative, and dx can be anything positive, you see? And then same thing for the y's. The y's can be anything positive, and then anything negative, okay? This one right here, I'll just leave it on the screen. You can pause the video and see what I did. I basically put the coordinates for each point. And then again, I looked from left to right for the y. I'm sorry, for the x. I looked from left to right. And I noticed, hey, it's at -3 for x. And then all of these numbers work for x, but then it stops at 4. So that's why the domain was x is greater than or equal to -3, but less than 4. And then for y, I looked here, -2, and then 4. So I put -2, less than or equal to y, less than or equal to 4. All right, so again, I mean, I'll put a couple of these up here. This worksheet, however, is not in the folder. So definitely what I would do is, if you can, pause the video. I'm just going to snap those two, try those two out. So pause and try it. You want to message me, Miss Mosey, did I get it right? I'll answer. And then there's another one you can try there. This is again not on in the folder. All right, that's enough for domain and range. So let's move on. So that's everything for domain and range. Now let's talk about evaluating functions. Somebody asked me, Miss Mosey, can you upload more problems? I think it was Bianca Harrell and whoever else wants them. Here's some more practice with evaluating functions. Oops. So if you want to pause the video and do a couple of these, you can. And I'm going to do 4 and 8 because they're circled. And then you can try the rest and then message me, anybody who wants to get some solutions. Okay? So pause the video, grab a couple of them on a piece of paper, and I'm going to do number 4 and number 8. I'm going to have this video be like an hour. Here we go. All right, so remember, evaluating functions. What's going to happen, okay, is like I've said before, we have a function. It's like a function machine. Numbers are going to come in, they get computed and plugged into a function, and what comes out when you evaluate it is the y. Please, 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 children. So we got, this is the input. It's the same concept. This is the output. It's the same concept when you graph points on a graph. You know what I'm saying? Like, hey, we plotted all these points, but guess what? Is this a function? Is it not a function? Well, the answer to this one is no, this is not a function. It doesn't pass the vertical line test. Why? Because when I pass that red vertical line through this circular so-called function, it passed through there 2 times, which means it has one x that's outputting 2 different y's. This is not a real scenario for everyday life. Like, there's nothing that would happen in life where to model it as a function, it would be a circle. It's just not, okay? All right, so this one too. See, this would never happen in everyday life. This is not a function that describes money. It's not a function that describes, you know, supply and demand of inventory. Like, you know, that's what functions do, is help us to describe situations in life. So again, If I put a vertical line through the function, see, it passes through there twice. All right, so back to this. So here they give it to you graphically, but then now they're telling you numerically. You could actually plug a bunch of numbers in, get a bunch of points, and you could graph. We could do that. We could literally start graphing these different functions, but they give us a start point. They're like, hey, plug in 3. Well, we could plug in -2, guys. We could plug in 0. We can get a bunch of numbers because x can be anything we want it to be. All right, that's that. So let's get to this one. So they give us this g function. It's equal to 3x minus 5. They want us to find basically what is my y value when when x is -2. What's the output? Okay, again, we're plugging in an x that they give us into some function they give us. We're going to get out a number. That's the output. That's the y. Yeah, okay, let me also write that. So remember, f of x equals y. Okay, whatever we plug in there, we get out y. Okay, so now I go back. I say, okay, g, I'm plugging in -2, 3, open parentheses, x, I'm plugging in -2, minus 5. Okay, then I grab my calculator. Did I bring it over here? Yeah, I did. Y'all know we can do this with our brains, but just in case. So for this one, I'm going to do 3 times -2, which I know is -6. And then I'm going to minus 5 from it. The answer is -11. So let's be clear. In the g function, when we plug in x at -2, we're going to always get equal -1. I could not plug a -2 in here 4 weeks from now, and I'll get out a 5 or a 10 or a 20. It has to always be -11. Okay? So that is one x with one specific y. All right, so the answer to this would be that y is equal to -11, and I could produce the point, right guys? -2 was my input. I got out -11. All right, so ultimately all you got to do is write this notation, and then that's the output. All right, number 8. This one, there's a w function. Instead of it calling x, they're calling it n. That's okay. N can be, I don't know, the number of ducks that came to the park that day. Just saying. All right, so now I'm going to plug in 3 for my n value, because again, n is equal to whatever's in parentheses here. Whatever they evaluate, that's what you're going to plug. 3 is going to be plugged in for n everywhere in the function. So n is equal to 3. So now that I plug it in for this notation, because that's what I'm finding, I put equal, -2. I do an open parentheses, 3, because n is right there being multiplied by -2. I put a 3 here, and then minus 1. Write again from left to right. W of 3 is equal to, and I go to the calculator. This is -6 minus 1. The answer is -7. I'm just going to show it to you. So again, -2 times 3 minus 1, -7. Okay, so we output -7. We're done. And what is the -7, you guys? Y equals -7. Mrs. Mosey, you say it so much, leave me alone. I love you. That's the point, okay? So the input is +3. The output will be -7, all right? So again, if you need to and you want to try these, and again, these are easy. So let me see if I can find a little harder with the square. That's a duplicate. Can't show you that one because it's an absolute value. I don't like so many pages and you'll know it. Okay, also just real quick, and then I'll go back, I'll make some up. Remember how we had this worksheet too? I think it's in week 6, I guess. But I think y'all have 2 copies or 1 copy of this. This is something else y'all can do for domain and range. Is it a function, not a function? If you have not done so. It's also in the folder. Okay, let's go back. I'm going to get on a sheet of paper because I don't have any that are quadratic with squares. And I think there is one on the test with squares. So give me a second. Paper. Let's see. Here we go. Oh my gosh, it's not hard. Give me a second, guys. Oh, here it is. Alright, so I'm going to make a couple up with quadratics. Or with squares. Okay, so what if they give us a function, and I'm also going to do y. I'm going to do more y than x. Okay, it'll make sense in a second. Okay, so what if they give us a function, and let's just call it, I don't know, let's call it s. So we say s of x is equal to x squared minus 6x plus 3. All right? And they say, what is the function for s when x is negative 3? So they basically want you to evaluate it, plugging in negative 3 where x is into this s function, and you're going to get out a y. Okay? So I'm going to say, all right, no problem. S, open parentheses, I'm plugging in negative 3 for my x, use parentheses, plug in negative 3, close it, square it, put a minus 6, open parentheses. So everywhere the x is into this function, we're plugging in negative 3 plus 3. I'm going to move super quick now. No calculator. So I know that, you have your calculator. I know that negative 3 times negative 3 is 9. I know that this is positive 18, and then plus 3. So s at negative 3 is going to equal, well, this is 27. 27 plus 3 is 30. Double check my math. So basically, that's the answer. And if they said, well, what is the ordered pair that's, produced, you could just say, oh, negative 3, comma 30. Okay, that's it. One more with the basically evaluating getting y. Remember, this is y. That's the output. Okay, let me do a trickier one. What if they give us g of x is negative 2x, I'm going to make this one up, cubed, minus 4x squared plus 5x plus 2. Dude, Miss Rosie, what's your problem? Well, what do you mean? You can do it. You have a calculator. It doesn't matter. They gave you this. You can find the cubic. Just make it a little tougher. It's okay. We have a calculator. So let's plug in, I don't know, 2. Let's plug in negative 2. Right? So everywhere that the x is, we're substituting in a negative 2. And let me also put that, ready? This means x is equal to negative 2. So right here where that x is, raised to the third power, I'm going to put a negative 2. Close it, then cube it, negative 4, open parentheses. For the x squared, I'm plugging in negative 2 for x, but I have to square it first. 5, negative 2, close it, plus 2. That's what we do. Now, watch how I do this, okay? So I'm going to do g of negative 2 equals, so the first thing is I'm not going to multiply, guys. Remember, we do exponents parentheses first. So I cover this up for a moment, or if you want, just rewrite it right here. Open parentheses, and I tell myself, what is negative 2 raised to the third power? Well, here's how I would do it on the calculator. See, I already know it's negative 8. But here's how you do it. Ready? Parentheses, parentheses, hitting the negative 2, closing it. And remember I told you about this raised to the power? So I'm going to hit that caret symbol, raised to the what? To the third. Tab over, I hit this to push it off of the exponent, enter, negative 8. Okay? So basically when I raised this number to the third power, it all evaluates to what, guys? Negative 8. And I leave it in the parentheses, and I know I still need to do my multiplication. Let's keep going. Now I drop down my negative 4. Do not multiply those together. You have to do exponents first. So I wrote it down. I'm putting another parentheses because I want to do negative 2 squared, which is 4. This is just simple multiplication, negative 10 plus 2. Right, now we're here. So now we go back to g at negative 2, close it, equals, multiply this for 16, multiply this for a negative 16, then drop those 2 down, or you can combine these two terms if you want, and that's negative 8. Either way, it didn't matter. But that's negative 8, subtract, keep the sign of the bigger number. Last time, g of negative 2. So we know that 16 from left to right, minus 16, see this is 0. 0 minus 8, negative 8. 0 minus 8, plus, bump back. Negative 8 is the answer. You tell your teacher, or me. Negative 2 is equal to g, the x function the function of g when x is -2 outputs a -8. I'm not going to do that to you, but I'm just saying. Right? So it takes a little work, but it's just evaluating functions. Okay, so here's the trickier ones. I'm almost to my end of video mark here. All right, so what if they say, hey, h of x equals 10. See that one? Equals 10. And then they say, but the h of x function is, I don't know, -3x plus 4. So when you see that this right here doesn't have a number in the parentheses, that means they gave you the y, we're looking for x. So again, what are you doing? You are finding x. So the substitution is that for this notation, h of x, what do you need to plug in? You need to plug in 10 for it. This is equal to 10, this whole notation. So when I come to my function, pay close attention, guys. I'm replacing h of x, which is my y value, with a 10. So right below here, I'm going to put a 10. Then I drop down my equal sign, and I drop down the rest of the function. And now I have a one-step or two-step equation, right? So I'm going to subtract 4 from both sides, because I want to get x by itself. This is 6 equals -3x. And then divide by -3 to both sides. And so x is -2. So what are we saying? We're saying that if the output was a 10 for the h function, and this is the h function they give me, then my x that should have been inputted to get out that 10 is a -2. And so -2 comma 10. That's easy. I'm going to do another one. Okay. Let's do this sheet paper. All right, I'm going to make it up. So what if they gave you, I don't know, f of x is equal to -7. The f of x function is equal to -10x minus 4. So what would be the x? So find x. Find this guy right here. You don't know who he is. You need to know what they inputted. You just know that was the output, and here's the function. So again, for this f of x, I'm replacing it with what? Because it's equal to -7. So I'm going to put -7 equals, and then I'm dropping down my function, and then I solve for x. So inverse operation, right? Numbers are going to go in this case to the left. The x is on the right. Plus 4, plus 4. This is a -3 equals -10x. Divide by -10. Divide by -10. Not divide by -10x. That means if you do that, there would be no x at all. You'd be bringing it down here in the denominator. Just the coefficient. So the answer is x equals a negative divided by negative is a positive 3/10. That's the answer. So when you put basically 3/10 into the function, this function, you're going to get out a -7. Okay, so hopefully that makes sense to you more now. And that's it. So that's everything I want to say on evaluating functions, besides the fact that graphs. Remember how the last thing, let me find my paper, guys. I know I got a lot of papers over here. This is my graduate homework. Move that out the way. I just had it. These right here. Remember how I could give you a graph like that? And I could say, hey, using the graph information, what's the x, what's the y? So here we go, ready? So notice for this one, they're saying, here's this function, and notice how they put y equals f of x. So again, we're plugging in numbers, we're getting out y values. So they're saying if you plug a 4 in for x, I hope everybody can see this. Okay, if I plug in a 4 for x in the f of x function, what will my y be? Listen again. If I plug a 4 in as my x, you see, what will be my y value? So that means I go to this graph and I say, well, where is x equal to 4? Well, again, this is the y-axis. This is the x-axis. This is 0, 0. Okay? So this is 0, and I'm jumping 4 jumps to get to x equal 4. Listen carefully. 1, 2, 3, 4. Oh, look, guys, x is 4 right there. Well, what's the y value? You're going to tell me 0, because you did not move up or down. You just went 4 to the right to get here. This point is 4, 0. All right, so the answer to this, that the output, the y value from the graph, is 0. All right, what happens when x is 6? When x is 6, what is the y value? So I go back here again, back to 0, 0. I jump 4, 5, 6. Pay attention. Right here is 6. And I go up 1, 2, 3, 4. So they're talking about this right here, which is, again, 6 to the right, 4 up. So what's the y value? Output will be 4. That's it on the graph. Now look at this one. For what x value does the function, the y value, equal to? Again, for what x value would I have to plug in so that y will be 2? Okay, well here you don't go to the x-axis because you don't know it. You go to the y-axis and find 2. So now instead of dealing with this axis, I'm going to deal with y. So I'm going to go up 1, 2, and I ask myself, hey, well, where am I 2 for y? Oh, here. And I'm also a 2 for y here. So there's 2 answers for x. And let's see. So if I go here, this is 1, 2 for x, and then up 2. So this is 2, 2. And then this one, same thing here. I would go 1, 2, 3, 4, 5, and then up 2. This is 5, 2. I know that's small, I know. Okay, 5, 2. So basically the answer is x can equal 2 and output a y of 2. X can equal 5 and output a 2. So we say for what x values is f of x equal to 2, we say when x equals 2 or 5. One more time. For what x value do I plug in and my y will equal 1? So I come back to here, and again, this was a 2, there's a 1 for y. So I go here, and I say, oh, there's a 1 right there for y. I keep walking along, and look, here is another 1 for y. I have 3 answers. Y is 1 right here. Now this was a little trickier. Hope everybody's paying attention. Yes, there's 3 answers. See, y is 1 there, there, and there. Now you have to approximate. This is not a perfect point. That one looks perfect. This one is not. Let me zoom in or focus it. Just to be clear. Okay, so here's how I'm going to do this. Ready? Let's do the easy one. This one's right there. So I'm going to say, hey, I went 1, 2, 3, right, for x, and then I went up 1. So this one right here is 3, 1. Now this one, I say, oh, okay, this is 3, this is 4, and this is 5. So this x value is between 4 and 5. I'll just tell you that this is 5. Okay, so I'm going to call that, I don't know, guys, 4.5. Why not? So this, I can't write or squeeze it in, but I'm going to try 4.5, 1. Then I'll go back to this guy and I say, hey, x is 0, x is 1. Now this does not look like 1.5 in the middle. I don't know, just for me it feels like it's a little over. So I'm going to call this, listen again, this is x at 0, this is x at 1. So that point right there, I'm going to call it, it's very close to 1, you see? So I'm going to call it like 1.7, 1.8, okay? So this one right here, this is where I have some more room, is I'm going to call it 0.7, 1. So what are my answers for this one? Well, y is equal to 1 when x equals 0.7, x can be equal to 3, and x can be equal to 4.5. So there are 3 answers. So if I were you, I'd pause the video right here, take a screenshot of those questions. Let me also zoom out. Maybe you can also get the graph, and you could try those other ones that are left. All right. So I think I'm going to end the video here. I'm trying to think, did I touch on everything? thing. I think I did. So again, remember, you have to be able to know how to take a function that they give you, plug in the x value into the function, get out your y value. Okay? You have to know how to do it off of a graph. That function notation we just did. You also have to know the opposite. Like, what if they give you the y value and you're looking for x? They give you the y, find x, and at the top somewhere they're going to define your functions, like g, f, whatever, let's just say. And then this is also good too to know. You see how it says f at -1 equal 1, h at 2 equals 7, so you can produce coordinate points like 2, 7, 1, -1. I think that's everything. I'm also going to let y'all pause the video if you want to do this one. There's another one for practice. If you want to pause it, try that one. I'm trying to think. Oh, mine is completely blank. It was domain and range. I already talked about determining a function. I think I've hammered that, so I'm not going to say it anymore about vertical line test and, right? Vertical line test. There is a bonus question. I'm not going to say what that is. I'll mess up the video here. I think I covered everything. And I wish you guys the best. Have an awesome weekend.